In this video, we will be talking about the ideal gas law. The ideal gas law is an equation that we will use to solve for unknown variables. The P is for pressure. The V is for volume. The N is for the number of moles. The R is the ideal gas constant. The T is the temperature. We have three ideal gas constants that we are able to use. We use them based off of the pressure we are given. If we are in atmospheres, we will use 0.0821. As we are in kPa, we will use 8.31. If we are in mmHg, we will use 62.4. We need to remember that we need to have our temperature in Kelvin and the volume will need to be in liters. In order to convert from milliliters to liters, we will use the conversion 1 liter is equal to 1,000 milliliters. In our first example, it is asking us what volume would be occupied by 0.625 moles of hydrogen at 4.00 atmospheres at 37 degrees Celsius. We will first list all of the variables. Our P is 4.00 atm. The V is the unknown. The N is 0.625. The R value is 0.0821. We know this because the pressure is in atm. The temperature is 37 degrees Celsius, but we need to convert it to Kelvin by adding 273. This makes our temperature 310 Kelvin. We first need to rearrange our equation to solve for the volume. In order to do this, we will divide both sides by the pressure. This will cause the pressure to be cancelled out on the left side. This now makes our equation V is equal to nRT divided by P. We will plug in the values for each of these variables. This allows us to get 0.625 multiplied by 0.0821 multiplied by 310, all divided by 4.00. When we plug this into the calculator, we will get a volume of 3.98 liters of hydrogen. In our next example, it asks us how many moles fill a 2.2-liter vessel with a pressure of 915 millimeters of mercury at 25 degrees Celsius. Listing our variables first, we get pressure is 915 millimeters of mercury. Volume is 2.2 liters. N is the unknown. R is 62.4. We know this because the pressure is in terms of mmHg. The temperature is 25 degrees Celsius, but we need to convert it to Kelvin by adding 273. This brings the temperature to 298 Kelvin. We first need to rearrange the equation to solve for N. In order to solve for N, we will divide each side by RT. This will cancel the RT on the right side, leaving only the N variable. This now makes the equation N is equal to PV divided by RT. We will plug in the variables to get 915 multiplied by 2.2, which will be divided by 62.4 multiplied by 298. When we plug this into our calculator to get 0.108 moles of gas. In the last example, it asks what pressure, in kPa, will be exerted by 0.45 moles of gas at 25 degrees Celsius if it is contained in a vessel whose volume is 650 milliliters. We will list our different variables first. The pressure is the unknown. The volume is 650 milliliters, but we need to convert this to liters. In order to convert milliliters to liters, we will divide the milliliters by 1,000. This will convert the milliliters to liters. In this case, 650 milliliters is equal to 0.650 liters. The number of moles is 0.45. The R value is 8.31 because the pressure is in terms of kPa. The temperature is 25 degrees Celsius, but we need to convert it to Kelvin by adding 273. This makes the temperature 298 Kelvin. From here, we will rearrange the equation to solve for pressure. We will divide both sides by volume to isolate pressure. When we do this, we get pressure is equal to nRT divided by V. We will plug in the values and solve. When plugging this into the calculator, we will get 0.45 multiplied by 8.31 multiplied by 298 all divided by 0.650. When we solve this out, we get a pressure of 1,714.12 kilopascals as the answer.